Okay, given that something is moving on a circle of radius 30 centimeters, perhaps a mass on a beam, moving in such a way that it accelerates at 2 meters per second squared in its direction of motion. That means acceleration is 2 meters, did I say 2 centimeters? 2 meters per second squared along the arc, in the direction of the arc at any instant. We want to figure out how many radians per second squared of acceleration that beam needs in order for that to be so. And it's actually very straightforward to do that without having to resort to meaningless equations and equations that are very difficult to remember. So again, an acceleration 2 meters per second squared in the direction of motion implies what? Angular acceleration alpha. Now the circle is of radius 30 centimeters. That's the radius of the circle about which this mass, whatever it is revolving. And we want to figure this out just based on common sense and the basic knowledge, the definition of pi and the definition of a radian. Pi being what? You should know instantly, ratio of circumference to diameter of a circle. And a radian being what? A radian being the angle with the property that that angle on any circle results in an arc distance out here on the circle that's equal to the radius. Okay, so angle equals arc distance equals radius, diameter, circumference is pi times diameter. Okay, well, so 2 meters is how many radians then? On a circle of radius 30 centimeters. Well, one thing we can reason out is that one revolution is equal to what? On the arc. The distance on the arc is the circumference, which is pi times the diameter, which is 2 pi times the radius, which is 60 pi centimeters. Ballpark 180 centimeters in the arc. We might or might not use that, but this is the accurate result. So there's one revolution on the arc. What's a radian? A radian's 30 centimeters on the arc. If you have a 1 radian angle, then the arc distance equals the radius. So radian is 30 centimeters on the arc. So what's 2 meters? Well, 2 meters is I've got something down here that's a little redundant and I want to get rid of it. Easy to explain. I wrote how many revolutions and how many radians. So I'm going to remove those question marks and those units because the units are implicit in the calculation, especially if I write it out properly. Okay, so we got 2 meters. Well, 60 pi centimeters is the arc distance of a revolution. So the arc distance of a revolution has the conversion factor 60 pi centimeters per revolution. 60 pi centimeters per revolution. I've written it out as 0.60 pi meters per revolution because obviously 60 centimeters would be 0.60 meters. Okay, I divide that into the 2 meters, and what do I get? I get 20 over 6 pi revolutions, which reduces down to 10 over 3 pi revolutions. Okay, what do I get here? Well, I get 2 meters over 0.3 meters, that's a 30 centimeters for an arc of a radian. 0.3 meters per radian. And what's that give me? It gives me 20/3 radians. So 2 meters is either 10 over 3 pi revolutions or 20 over 3 radians. So the 2 meters per second squared could be written in either of 2 ways. 2 meters is 10 over 3 pi revolutions, so we have 10 over 3 pi revolutions, and that's still per second squared. Or we could write the 2 meters as 20/3 radians in this context. So we'd have 2 meters per second squared being 20/3 radian per second squared. Now there is a formula, but this is why the formula works. Okay, what we see is the acceleration equals the radius of the circle times alpha. Okay, and in this case, the radius of the circle is 0.3 meters. So alpha equals, excuse me, acceleration divided by the radius, which is 2 meters per second squared, divided by 0.3 meters, which is 20/3 radian per second squared. Now if I multiplied this by, what, 1 radian per 2 pi revolutions, I said that wrong, 1 revolution per 2 pi radians, I still said it wrong. Something's not firing here. 2 pi radians per revolution. If we multiply 10 over 3 pi revolutions per second squared times 2 pi radians, if I write it down, I'll write it correctly, per revolution, okay, we get what? The pi's divide out, 10 times 2 is 20, we get 20/3 radian per second squared. So that this means the same thing as this, which is this, and we can apply this formula, but better we can understand this formula. And then the bottom line is that if we know how many meters per second squared, we can just change that many meters to radians on the circle, whatever the radius of the circle is, and we get the acceleration in radians per second squared. Okay. Now, I see this written here, and this comes out of something completely different, which is something we did earlier. So I'm going to comment on that in a minute, as soon as I figure out where that came from. I mean, I remember that result. Yeah, okay, I know where that came from, but we'll pick up in just a minute.